Hey everybody, this is Larry. This is week one of the August weekly premium challenge. Hit the like button, hit the subscribe button, join me on Discord. Let me know what you think about today's premium challenge problem. Did I solve this one? I don't see a solve button, but sometimes there are bugs. Ooh, we have a new one for Larry today. New video, so check that. Excited or is excited for a new video. But 314 binary tree vertical order traversal. Okay, given the root of a binary tree, return the vertical order traversal of the node's value. If two nodes are on the same road and column, the order should be from left to right. Okay, I mean, seems pretty straightforward in terms of understanding. It's just that on the recursion, we will, yeah. But the left to right part is a little bit awkward with respect to like the 10. Oh, wait, what? From top to bottom. Okay, so I was wrong. It is very clear. It's from top to bottom, right? I'm trying to think. I mean, the short answer for this one is just traversals, right? Because you go left, you minus one on the vertical column. You go right, you plus one. I think that part is pretty straightforward. Then the only thing that comes to mind is that, of course, you don't want to sort it afterwards, and you can. And maybe it'll even be fast enough because n is 100 is definitely fast enough. But I think there's a way to challenge yourself because I think given that n is 100, you could do a lot of things and just kind of construct these coordinates and sorting, and that's fine. But I would challenge yourself to kind of see if you can do it in a one pass kind of way with no sorting, or I don't know if I would call it one pass, but just like doing it in the order in which the answer would be posed, right? So that means that we want to go top first and then left first, right? I think that's pretty straightforward, honestly, unless I'm missing something obvious, which makes it like less obviously. And the reason why I say that is because if you go left first, if you kind of think about in an in order kind of. Is it in order? No, pre-order, right? If you're doing pre-order, then you always get the top level first, and then yeah, and then if you go obviously left first, you'll see the left nodes earlier, right? And two nodes that kind of merge in the same place will always be the right node and the left node, because that's just how they kind of. Oh, is that true? Maybe not, because I guess the 10 here can have a left node. Well, no. I mean, it's still kind of true. It's just maybe what I'm saying is silly. Right? Actually, is that right then? In that case, you would put the 5 and then the 10. But if you try to do it in an in-order traversal type thing, that might actually be wrong, right? I'm trying to see if there's another example. But for example, you just imagine that this 10 has a left node that's, I don't know, another number. In that case, if we do an in-order traversal, no, I guess it is still right. Yeah, I think it's still right, but it is definitely very wonky the way that I'm thinking through it, for sure. Okay, let's just try it, and if not, then we learn something. I think, I think that's how it goes sometimes, and that is a fine thing to do, especially with exploring. Remember, you rather make mistakes now when you're practicing than on a contest or on an interview or something like that, right? In theory. So yeah, so okay, let's see. We have. Yeah, I mean, this is just a regular in order, right? We have a node, we have the, I guess like the y-axis, the vertical axis, and then the horizontal axis, so x, maybe just xy, I don't know why I would say yx just to confuse myself. And then, yeah, and then maybe we just kind of group them together. The reason why is just because you don't know how long far to the left you can go. I mean, I guess you could do it in another pass, but I don't know. So maybe I'll just write something lazy and have something like f is equal to list, right? And then now, yeah, and this basically f of y is the nodes in order, or should be. Oh, the reason why in order doesn't work. the reason why in order doesn't work is because you could have 10 that goes to the thing, and then to a left, which goes to 5. I'm just trying to think. There is some like weird diamond-y shape thing, reverse diamond-y shape where it doesn't work, right? Because basically, yeah, I don't think in order works, because I was trying to think through this case, but for some reason I kind of lost it. And I want to draw it out real quick, actually, so then maybe, I mean, I don't think we should have done it anyway. I just wanted to explore, because there is a much easier way, which is with breadth first search and not depth first search, to be frank, which I knew, but I thought I could maybe play around with it. But the case that I was thinking of, but kind of lost in a second, is let's say you have this node, let's just go with 1, you have this, 2, 3, whatever. Oh, technically they don't go to the same node, sorry. All right, let me clear this up real quick. Right, this goes to 4 and this goes to 5, they're in the same place, but then now this 5 maybe 6 and then 7, right? And then this 4 goes to let me change the color to. So yeah, so we have to do it with breadth first search, but I'm just drawing the case. But you can see that the 4 goes here to, what happened? I don't know, but let's do it again. Let's say 8 and then 9, right? And technically speaking, remember that, wait, am I confused? Maybe I'm just very confused, honestly. I think the left to right part is not super clear to me what it means. Because if you have this, I guess I've been going back and forth with what left and right means. Because here, do you just assume that everything here, even though this goes past to the right, that 9 is to the left or to the right, right? To me, it is unclear, I suppose. I mean, maybe, I don't know. I feel like people always read things differently than I do, or not differently, but more certainly, right? And the reason why I have all these uncertainty is not necessarily because, I can figure it out, but it's just that you can read it both ways, and when you do, I've done at this point, I don't know, maybe 10,000 problems, give or take, maybe more even, honestly. I mean, and maybe more if you duplicate them, or not, or if you don't dedupe or whatever. But why I say that is because I know a lot of cases where problem setters will kind of make tricky inputs for you, or like do things in a way that is quote unquote surprising to kind of trick you. Be like, hey, you read this, well, yeah. And I'm just kind of like very defensive as a result. Maybe you could call it PTSD or drama or something, trauma. But yeah. I lied. I didn't put it on the board, even though I did. Did I put it on the board? I don't remember. But in any case, this is what I was saying. I'm sorry if I had forgotten. I was thinking, like, in this case, then, is this to the left or is this to the left, right? I mean, I think probably this one with the 9 to the left makes more sense, but it's also, like, not super clear to me, right, what to the from left to right mean, right? So, yeah. But anyway, we can just guess and then YOLO, because this is a contest. Oh, sorry, this is not a contest. We'll just keep it this way, right? If not, then we'll just make changes. But anyway, so then now we have a node, so we want to do it, and I lied, this is not in order, this is pre-order, right? Because we want to do it top first. Oh, maybe that's where I got a little confused. Because if we want to do it top first, oh yeah, so I'm wrong, okay. Yeah, this doesn't work. Let me go back. I think I got confused with the left to right. But here, it's an example of top first doesn't work. It's because if you can't do it in order, pre-order, doesn't matter, but if you do it in a depth first search kind of way, you do 1, right? And just looking at like down the middle, you go 1 and then 4 and then 7 and then 5 and then 9, right? Which is not what you want, because 5 should be after 4 and 9 should be after. Oh, actually, in this case, I lied. I already forgot. So this is a 7 and this is a 9. But you get my point, right? Is that going vertically, this is just wrong. So okay. I mean, if we know the case, then we shouldn't do it. So we can just do a breadth first search like a normal person. Yeah. And, right. But the same idea, really. So then q.append root at 0, 0. right? And then we have node xy is equal to q dot pop left, and then yeah, so then f of y is equal dot append node dot value. And technically, we don't need x because we're doing it in breadth first search kind of way, right? So that we know that the next number that we're up, the next layer is always going to be just coming in afterwards. So it's actually not necessary, maybe. But maybe we can keep it just for debugging reasons in case, as you can tell, I'm not very confident today. So if you need to plan for your code failing, then it's not a confident day, even if that is the more responsible thing to do. But yeah, then now for child in node dot left, node dot right, you can say if child is not none, then yeah, and q dot push append. I forget append, right? Man, I've been doing this every day. How can I? Child, I guess x plus 1. Okay, fine. Well, x just so that I could do this. But maybe we can keep this as -1, and then to the right will be +1, right? And then there's now child delta, so then now this is x plus delta, right? And again, yeah, and that's it. And then now we can say maybe we get the min y, and then just increment by the value. So maybe you could do f dot keys. I mean, you can also sort and then just go through them, but there's no gaps, right? Because you just can't. You're going -1 + 1, so there's no gaps. So you can just do something like and then maybe max k, min k, right? Something like that, right? So min or maybe just left, right, right, and then yeah. Maybe you have answer for I and range from left to right, inclusive answer dot append f of I, and then that should be good, hopefully. Yeah, looks okay, right? So let's give a quick submit. And oh, the empty tree. See, they always try to trick you. What? I mean, maybe I should have looked at the details about 0, but this is like such a like, did I not consider it? Yes. Is it interesting? I don't think so. Right? Like, if your input is literally one if statement for all the cases, then it's not an interesting input, right? It's what I feel. I mean, it might not be. I mean, look. See, I mean, I don't know. If something is 0, 0, return empty array. It's not a problem solving. It's just, I don't know. Maybe I should have considered it. I'm just a little bit salty. I don't know. But that is all I have for this one. This is going to be linear time, right? Linear space. That's just how BFS works. And we look at each node once. Yeah, and we also go for the keys, which is, I guess, still linear-ish. Or, well, technically, probably sublinear, but too lazy to figure out the math. So, yeah. And I think it's actually worst-case linear, though. Because I guess it's not sublinear, because if you have only... If your tree is a linked list, then you would have every node, so that'll be linear in any case. Anyway, everything's linear time, linear space, and that's all I have for this one. Let me know what you think. Thanks for watching. Stay good, stay healthy to good mental health. I'll see y'all later and take care. Bye bye.